or laptop, send requests to this access point, which then forwards those requests to the internet, retrieves the responses, and send them back to the clients. But what if we as a hackers replace this access point with our computer? In other words, what if we create a fake Wi-Fi network that provides real internet access? When people connect to our network, we automatically become the man in the middle because we are now acting as their router. We won't need to exploit any protocols or run complicated attacks. People will willingly send us their data because they think they are connected to a legitimate network. This is where things get really interesting. By creating our own Wi-Fi networks, clients who connect to it will automatically send all their requests through us. And since we are the router, we can see everything they do. We will forward their request to the internet and send back responses, just like a real access point. But in the process, we will be able to intercept, sniff, and manipulate the traffic however we like once the clients are connected. We can launch all of the man-in-the-middle attacks we have demonstrated earlier without needing to run ARP spoofing or anything fancy. All you need is computer running Kali Linux, internet access, and a wireless interface capable of broadcasting the Wi-Fi signal. Now let's break down what you will need. Internet connection. This could be through a Wi-Fi, Ethernet, a 3G 4G dongle, or even a virtual interface. Wi-Fi interface, not just any Wi-Fi adapter, will work. It needs to be capable of running in access point mode. Once you have set up the necessary hardware, we will be able to start broadcasting our fake network. With this setup, our computer will act like a router. Clients who connect to the network will send all their traffic to us by default. So we won't need to worry about ARP spoofing. We are automatically the man in the middle. From there, you can run all the attacks we have covered previously or any other man in the middle attacks techniques, like sniffing passwords, injecting malicious code, or redirecting user to a phishing site. Now, you could configure all of this manually. For example, you could set up the wireless interface to broadcast the signal, configure routing between interfaces, and ensure that traffic is forwarded properly. However, since this is the ethical hacking course, I want to show you a faster and more straightforward way to achieving the small result. The tool we will use is called the Mana Toolkit. This is a powerful suite of tools that allow us to automatically create a fake access point, sniff traffic, and even bypass HTTPS in some cases. It has three main scripts to choose from. Start no upstream.sh. This creates a fake access point without internet access, which is not very useful for our purposes. Start net simple.sh. This sets up a fake access point with internet access. Next, start net full.sh. This also provides internet access but tries to automatically sniff traffic, which often fails. I recommend starting with not simple and then launching another terminal to run BetterCap for sniffing data and bypassing HTTPS, as we have shown in previous videos. Once our fake access point is live, clients will connect thinking they are accessing the internet. In reality, their traffic is flowing through our machine. We will use tools like BetterCap and Wireshark to analyze and manipulate the data. We can capture usernames, passwords, session tokens, and much more. This method of creating a fake access point is a powerful way to become the man in the middle and run a variety of attacks. It eliminates the need to exploit ARP protocols or other vulnerabilities. Clients will willingly send us their data.
डेवऑप्स इंजीनियर बनना अच्छी बात है, बट डेवऑप्स के लिए कंप्यूटर नेटवर्किंग को इग्नोर करना और वीपीसी के कॉन्सेप्ट्स को इग्नोर करना ये तो सही नहीं है। और इसी के लिए आज हम लोग पढ़ने वाले हैं कंप्यूटर नेटवर्किंग फॉर डेवऑप्स इन वन शॉट, जहां पे हम लोग एक ही वीडियो में सारे कंप्यूटर नेटवर्किंग के कॉन्सेप्ट्स देखने वाले हैं कि कंप्यूटर नेटवर्क होता क्या है, इंटरनेट काम कैसे करता है, क्यों कंप्यूटर नेटवर्किंग यूजफुल होता है डेवऑप्स इंजीनियर्स के लिए, ओएसआई मॉडल क्या होता है, टीसीपी आईपी मॉडल क्या होता है, आईपी क्या होता है, सबनेटिंग क्या होता है, डीएनएस क्या होता है, फायरवॉल्स क्या होता है, नैट गेटवेज कैसे बनाते हैं, पिंग, ट्रेस रूट, एनएस लुकअप्स, ये सारी चीजें भी आज हम लोग देखने वाले हैं, प्रैक्टिकल यूजेज होने वाला है। लोड बैलेंसर्स क्या होते हैं डेवऑप्स में, कंप्यूटर नेटवर्किंग में, और वीपीसी पियरिंग ये कैसे होती है, ये सारे चीजें हम लोग एक ही वीडियो में देखने वाले हैं। तो आज की वीडियो बहुत ज्यादा इंपॉर्टेंट होने वाली है। जो ये वर्कशॉप है कंप्यूटर नेटवर्किंग की, ये बहुत ज्यादा इंपॉर्टेंट होने वाली है आप सबके लिए। तो फटाफट मुझको चैट
Net Discover I-5880 range, in my case 192.168.73.1/24, and hit enter. Net Discover has completed the scan and it found all the devices on our network. Now let's go back to Wireshark to see what's happening. Before we check for notification, let's analyze the packet generated by the scan. We can see there is a device identified by its source IP, broadcasting to the entire network. It's asking questions like who has this IP and tell this IP. This is essentially Net Discover in action, trying to map every possible IP on the network and asking them to report back to the source, which in this case is the machine with IP 192.168.73.189. So we can easily deduce that someone on the network is attempting to identify all the connected devices. Now let's check for any alerts. If we go to Analyze and select Export Information, you will see that Wireshark has flagged an ARP packet storm. This tells us that a simple device is sending a large number of ARP requests, most likely trying to gather information about the connected devices. This is a clear indication of suspicious behavior. Now let's perform an ARP poisoning attack and see if Wireshark pick it up. I am going to execute attack using BetterCap in my Kali machine. Once the attack is in progress, let's head back to Wireshark and analyze the results. Look at this, Wireshark has flagged another issue, a warning about a duplicate IP address. This tells us that our router's IP address is now associated with the two different MAC addresses, meaning someone is tampering with our ARP table. This is the result of an ARP poisoning attack, where the attacker positioned himself between the router and the target device to intercept communication. So, how can we protect ourselves against ARP poisoning? One way is to use static ARP tables. Let me show you how we can. Let me show you what I mean. Open terminal and enter ARP A. You can configure each IP address manually to map it. You can configure each IP address manually to its corresponding MAC addresses. In this case, when you set your ARP table to be static, any attempts to change it, like an ARP poisoning attack, will be blocked by the system. The downside is that in large networks, managing static ARP tables is an impractical, but in smaller setups like a home or a small office network, this method could be highly effective in preventing ARP poisoning attack. And that's how you can use Wireshark to detect suspicious activity on network, including ARP request storms and ARP poisoning attacks. We have also discussed how you can defend against these attacks using static ARP tables. Thanks for watching and see you in the next video. Hello everyone, welcome back. In the previous lectures, we learned how to detect ARP spoofing attack by manually analyzing ARP tables. We also explore how to install tools like ARP to automatically detect ARP spoofing without needing to check ARP tables manually. Plus, we use Wireshark to detect other suspicious activity on the network. While this is a great, there are few limitations. First, these are all detection techniques. So even if we detect someone intercepting our connection, there is not much we can do besides disconnecting from the network. On a public network, like at an airport, hotel, or college, disconnecting and finding another network is our only real option since we can't change the password. The second issue is that this method only works when the attackers become the man in the middle. But what if they are using another method? For example, they could be running a fake access point that we accidentally connect to. Or maybe we are on a public Wi-Fi and either the network admin or a hacker has gained access and is collecting data. The detection method we previously discussed won't be effective in these scenarios. That's why In this lecture, I am going to show you two solutions that can help you to protect your data. Whether you suspect you are under attack or are connecting to a network you don't control, the solution to all of this issue is to intercept your traffic. The solution to all of this issue is to encrypt your traffic. When your traffic is encrypted, it does not matter if someone intercepts it because the data will be in a form they can use. Several methods can achieve this, and I will explore how they work as we can go through it. Let's take a look at how an attack might work first. I already have beta running here, and as you can see, it's gathering information. If we click anything, you will notice that the domain is being detected. Now, let me quickly log into a website. You will see that this login attempt is detected with the username. Now, let me quickly log in into the website. Press login button and enter password paste and login. Now login successful. Let's move to the Kali machine and scroll down for login credentials. Now you will see that this login attempt is detected with the username admin and the password is test. Now I will open a new tab and go to linkedin.com. Type www.linkedin.com. Notice that it loads over HTTP instead of HTTPS. And if I log in here, and I will be able to capture the password. My Kali machine can intercept all the data sent between my Windows machine and the websites. Now enter username s3cloud@gmail.com and password is test 123456789 and click sign in. Now let's move to the Kali machine. If I log in here, I will be able to capture the password. My Kali machine can intercept all the data sent between my Windows machine and the website. To stop this type of attack, the first thing we can do is install a browser plugin called HTTPS Everywhere. So open browser and search HTTPS Everywhere plugin or add-ons. And here is the first website of plugin. Add to this into your browser. Once installed, it sets to off, but when we click it, we can turn it on. This plugin essentially works by enforcing HTTPS connection for websites that support HTTPS but may default to HTTP. While this is a great solution, it is not perfect. For example, if we go back to a website that only supports HTTP, like oneweb.com, login in will still expose my password to anyone. If we go back to a website that only supports HTTP, like OneWeb, login will still expose my password to anyone intercepting the connection. In this case, HTTPS alone is not enough to fully secure the connection. To enhance your security further, I recommend using a VPN, Virtual Private Network. A VPN encrypts all of your internet traffic. Not just the traffic on HTTPS site, making it much harder for attackers to intercept or analyze your data. Here is how you can set up a VPN. Choose a reputable VPN provider. Look for one with strong encryption and no logs policy. Install the VPN application. Download and install the app from your provider's website. And third step is open the app and connect to a server, and from that moment on, all of your internet traffic will be encrypted. And step 4, use tools like IP leak test to ensure your real IP address is hidden and your VPN is working correctly. By combining tools like HTTPS everywhere with a VPN, you can significantly increase your online security and privacy. Even if an attacker intercepts your traffic, they won't be able to read it. So, in summary, while HTTPS helps secure specific websites, a VPN adds a more comprehensive layers of protections, especially when using public or unsecured network. Stay vigilant and always layer your security to stay protected online. Thanks for watching, and I will see you in the next lecture. Hello everyone, welcome back. Now that we have learned the basics, it's time to take things a step further. In this video, we will explore how to gain access to different computer systems, whether it's a computer, server, or any electronic device. Yes, you heard that right, any electronic device. So, what is a computer? When I say computer, I don't just mean desktops or laptops. It could be your phone, TV, router, or even a web server. All these devices work like computers because they have an operating system and application installed on them. They might look different, but deep down, they are very similar to your personal computer. Targeting personal computers, today we will focus on how to gain access to personal computers, specifically Windows and Linux devices. But the good news is, once you understand the basic, you can apply the same technique to other devices like phone or web servers. All these devices function similarly when it comes to security and access. Now, when it comes to gaining access to this device, we have two main approaches: server-side attacks and client-side attacks. In server-side attack method, we don't need any interaction from the user. It's usually done on the web servers or applications where no one is actively using the device. Here we will focus on attacking the operating system or the app installed on it to gain access. Second, client-side attack. This method needs the user to perform an action like clicking on a file, installing an update, or downloading something from the internet. Information gathering becomes important in this case because knowing the user's behavior can help you plan the attack. Once you have gained access, whether through a server side or client side or physical method, we will explore the next steps. This could involve exploiting the system further or gaining access or gaining higher privileges, allowing us more control over the device or network. So that's the big picture of what we are going to cover. Every device you interact with is a computer in some form, and the methods to gain access remain quite consistent. Stay tuned as we dive deeper into these techniques and learn how to secure system against them. So see you in the next video. Welcome back friends. In the upcoming lectures, we are diving into server-side attacks. But before we jump in, let's first understand what server is and how to attack it. To practice these attacks, we need a virtual machine acting as a server, just like we had a Windows machine to practice attacks on regular users. Now we need a server-like virtual machine. This will allow us to simulate server-side attacks and understand how hacking server is. This will allow us to simulate server-side attacks and understand how hacking servers work. The machine we will use is called Metasploitable, a Linux-based virtual machine designed for security testing. It is preloaded with typical server services and web applications, which we will target in our future lessons. You can download Metasploitable from the link I have provided in the lecture's resources. Once you are on the download page, click the download button to download zip file. As you can see, the download getting started. Once downloaded, you will get a zip file. And I have already downloaded and extract it here inside the folder. You will find several files and we will use this to set up a virtual machine. Let's create a new virtual machine in VMware. So first of all, we need to open VMware and open a virtual machine. Select the folder and open VMX file and press the power on this virtual machine. The machine is now up and running. So it's asking for the username, which is MSF admin, and the password is also MSF admin. Remember, when typing the password, nothing will appear on the screen for security reasons. One important thing, never expose this machine to the internet as it is intentionally vulnerable. Right now, it is safely isolated in our lab environment. When you are done using the machine, type sudo power off to safely shut it down. This ensures the machine power off clearly. So that's it. We have successfully set up our metasploitable virtual machine, which we will be using in upcoming lessons to explore server-side attacks. Now, it will ask for admin password. So I will enter MSF admin. So don't worry about the terminal interface. We will go step by step and explore everything along the way. See you in the next lecture.